Hello everyone, I am Nivedita Jaina from Ambika Prasad Research Foundation. Welcome to all of you to our channel Biodiversity and Conservation. So in the previous part, we have discussed about the environmental chemistry, the classification of components, chemical kinetics, chemical energy, and today in this part, we are continuing that, which are about the chemical equilibrium, the carbonate system, saturated and unsaturated hydrocarbons, and radioisotopes, etc. So let's start. So what is chemical equilibrium? Once the reaction has reached the state of equilibrium, the concentration of reactants and the products attain certain fixed values and do not change with time, provided the conditions do not change. These equilibria are dynamic in nature in that, although the concentrations do not change but the reaction itself does not cease to occur, the rates of the forward and backward reactions have the same value, and so the extent of reaction in both directions remains the same. Hence, there is no change in the concentrations of reactants and products. So some of the features of chemical equilibrium are: these reactions do not go to completion. If a reaction is initiated by taking reactants only, the concentrations of the reactants would decrease with the progress of the reaction, and those of products increase until the equilibrium is established. At equilibrium, the rate of forward reaction will become equal to the rate of backward reaction. And despite the establishment of the equilibrium, the reaction in both directions will continue to occur at equal speed. Then coming to the gas solubility in water, gas solubility in liquids deals with the concept of gas dissolving in a solvent. So, for any substance, solubility is the maximum amount of solute that can be dissolved in a given solvent at a particular temperature. The gas solubility in liquids is greatly affected by temperature and pressure as well as the nature of the solute and the solvent. So there are many gases that rapidly dissolve in water, while there are gases that do not dissolve in water under normal conditions. Oxygen is only sparingly soluble in water, while HCl or ammonia readily dissolves in water. Some of the factors affecting solubility are effect of pressure and effect of temperature. So the effect of pressure, it has been found that the gas solubility in liquids increases with increase in pressure. To have a better understanding of the effect of pressure on gas solubility, um, let's discuss or consider a system of a gas solution in a solvent in a closed container in a state of dynamic equilibrium. Now the solution is in equilibrium and hence the rate of gaseous molecules entering the solution is equal to the rate of gaseous molecules leaving the solution. Then now suppose we increase the pressure of the system by compressing the gas molecules present in the solution. As a result of an increase in pressure, the gaseous molecules will now be concentrated in a smaller volume. This will result in an increase in the number of gas molecules per unit volume available above the solution. Since the number of gas molecules present above the solution has increased, the rate with which the gas molecules will be entering the solution will also increase. The end result is an increase in the number of gas molecules um, in the solution until the new equilibrium point is attained. Thus, the solubility of gases increases with increase in the pressure of a gas above the solution. Henry's law gives the quantitative relation between pressure and gas solubility in a liquid. It states that the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of liquid or solution. Then coming to the carbonate system. So in environmental chemistry, one of the most important systems in the oceans is the carbonate system, a buffering system that helps to maintain the pH of seawater to within a narrow range. With the sole exception of the chemistry of water itself, this is by far the most complex equilibrium system, and it touches upon every aspect of the earth science, meteorology, geology, oceanography, and certainly biology. Within oceanography, it plays an important role in each of the four reactive zones of the oceans, in the air-sea interface, in the chemistry of seawater, in the biogeochemistry, and in the deposition and dissolution of marine sediments. The carbonate system has been a major participant in the evolutionary history of the atmosphere, hydrosphere, and lithosphere, and it may play a major role in the future by removing anthropogenic carbon dioxide from the atmosphere. Over 95% of oceanic carbon is in the form of inorganic dissolved carbon. The remainder is comprised of various forms of organic carbon, namely living organic matter as well as particulate and dissolved organic carbon. Saturated and unsaturated hydrocarbons. So what are first hydrocarbons we have to know? Hydrocarbon is a chemical compound that consists only of hydrogen and carbon. It is made up of two elements, hydrogen and carbon. Um, since methane, ethane, ethine, and so on are all made up of only two elements, that so that hydrogen and carbon. So these are all hydrocarbons. And petroleum, often known as crude oil, is the most important natural source of hydrocarbons. It is extracted from underground oil deposits by drilling oil wells. Hydrocarbons can also be found in natural gas found above petroleum deposits. So, types of hydrocarbons. Hydrocarbons are of two types, which are saturated hydrocarbons and unsaturated hydrocarbons. So, the saturated hydrocarbons are one in which all of the carbon atoms are connected by a single bond. Saturated hydrocarbons are also called alkanes. So, an alkaline is a hydrocarbon in which the carbon atoms are only connected together by a single covalent bond. In an alkane, there are no double or triple bonds. As a result, the hydrocarbons methane, ethane, propane, and butane form a series of compounds known as alkanes. And all of these saturated hydrocarbons have N at the end of their names. Then the unsaturated hydrocarbons. An unsaturated hydrocarbon is one in which two carbon atoms are connected by a double bond or triple bond. Two important unsaturated hydrocarbons are ethene and ethyl. because ethine contains a triple bond and ethene contains a double bond between the two carbon atoms. A double bond is formed by sharing two pairs of electrons between two carbon atoms, whereas a triple bond is formed by sharing three pairs of electrons between two carbon atoms. Unsaturated hydrocarbons are typically obtained from petroleum through a process known as cracking. And unsaturated hydrocarbons are of two types: those containing carbon-carbon double bonds called alkenes and those containing carbon-carbon triple bonds called alkynes. Then radioisotopes. Radioisotopes are the unstable form of an element that emit radiation to transform into a more stable form. And radiation is easily traceable and can cause changes in the substance it falls upon. These special attributes make radioisotopes useful in medicine, industry, and other areas. Most radioisotopes are artificially produced in research reactors and accelerators by exposing a target material to intense particles such as neutrons or protons, followed by different chemical processes to bring them into the required chemical form. These are an effective tool used in radiopharmaceutical sciences, industrial applications, environmental tracing, and biological studies. Aside from research reactors and accelerators, they are also obtained from radioisotope generators.